In our last video, we have talked about the helical theory. I hope you have gone through that specific video. If you have not, I will put the link here. And in this video, we are going to talk about another amazing fact, which is about the faciality. Now, when we talk about the pericyclic reactions, all we have to think about is orbital interactions, right? So let me take an orbital to explain to you this scenario. Let's say this is a p orbital, right? Because most of the time when we're talking about the pericyclic reactions, there are p orbitals which are interacting with each other. So that's why I have taken a p orbital. Now, when we look at an interaction, our orbital can interact with another orbital in two ways, right? First is through this part, and the second way is through this part. Based on these two ways, right? Based on these two ways, our pericyclic reaction can divide it into two parts, which we call faciality. There are two types of faciality when it comes to an orbital interaction. Let's take a quick example, right? You will see that when we talk about pericyclic reactions, which we have talked until now, right? There we have talked about several pericyclic reactions and some examples throughout this video series. There are two orbitals. Mostly there are two orbitals. Like, let's take an example like this. Here, look at this one. So these are the two orbitals. These are the two p orbitals that are going to be interacted with another segment, right? Like this. So if you remember this particular reaction, right? So this one comes here and comes here and comes here. We have the final product as like this, right? This is our final product. So when you look at this specific reaction, right, you will see these two orbitals, right? Look at this. These two orbitals has to interact with these two orbitals in order to form this particular product. So every time when you look at a particular pericyclic reaction, you will see pair of p orbitals, right? Pair of p orbitals are going to interact with another pair of p orbitals. So as I have told you in earlier this video, there are two ways which these interactions can happen. So let me introduce these two ways of which the orbitals are going to interact with each other. Now, if we look at specifically about this segment, right? Specifically about this segment, I will put positive and negative to these two orbitals, just for simplicity, right? This orbital, right? This orbital, look at this orbital. This orbital can go to the other segment through this part. So this is going to form the interaction through this part, right? Not from the negative side. It's going to form the interaction from the positive side. While the same happens here for this orbital also, the interaction will be formed from the positive side. Let's say this scenario, right? This is the first scenario. So this is the first scenario. Now, if this scenario happens, right? If the both orbitals form the interaction in the same side, it can be either positive or negative, right? It can be either positive or negative, but both interactions, right? Both interactions happens to be on the same side. It can either positive or negative. We call these particular interactions as suprafacial. Let me write it. So we denote it by S. Okay. We denote it by S. Again, I have to tell you that these two interactions, these can be either from positive or negative, can be both, right? But these two interaction, both of these two interaction must be from the same. It can be either positive or negative. Now the second case, right? Second case is the opposite. Now here you have the two orbitals, Now I will put the positive and negative charges. Not the charges, right? These are not charges, right? You get the idea. I will take yellow color, right? So let's say our two interactions happens like this. One from the positive side and the other from the negative side. As you can see, now the two interactions are from the different sides, right? It's not like this. This is what I'm telling you, right? In this case, both the interactions has to be from the same side. It can be either positive or negative. If it happens like this, one is from the positive and the other one from the negative, then it's not suprafacial. In this scenario we call it antrafacial. Let me write it. We denote it by simple A. Okay. So this is basically the phi systems, right? This is phi systems. And there are also some scenarios where the bond breakage can happen, right? Let me give you an example, right? So let's say you have a sigma bond. Here this is a sigma bond. Now with another two orbitals, right? With another two orbitals, this particular sigma bond is going to be broken and form new bonds between, right? So like this. Just like this. So a new bond between will be formed like this. So this particular bond, this bond is going to be broken, right? The two new bonds are being formed between this and this. So let's take that scenario, okay? So let me take the sigma bond. So here the sigma bond scenario. We hardly find situations in pericyclic reactions specifically, right? But we will talk about the sigma bonds also. Now if you look at a sigma bond here, there are two orbitals. This is the one s orbital, sorry, this is one particular orbital and this another one orbital. These can be like sp2, sp3 likewise. Now let's say when our bond breakage happen, right? This is a bond. I hope you are familiar with this. This is a bond. Now when the bond breaking happens, right? When this bond break, this orbital, look at this. Again, I will put the positive and negative charge here. I will be positive here and negative here. So let's say our interactions happen with other party like this. The positive side goes away and interact with each other, and this positive side will go away and interact with another orbital. Now you will see both the orbitals, right? This orbital and this orbital, both two orbitals are going to form interactions with another party from the same side, from the same part of the orbital, right? Both from the positive part. So I hope you can guess what is the type of the faciality. It's suprafacial. So it's basically simple as. Now what happens if the case is the other way around? Here we have the two scenario. Two orbitals are having a bond with each other. Now what happens is the bond is going to be broken, right? While the bond is breaking, the two new interactions will be formed between these two orbitals. So it can be either from the positive part, like I mean the new interaction can be formed in between the positive or the negative. In this case, we have talked about the positive interactions, right? Both the orbitals form the new interaction from the positive part. But in this scenario, let's talk, one is forming the interaction from the positive part while the other goes and form the interaction from the negative part. This can happen also. Now the interactions are changed, right? Interactions are opposites. So in this case, it's not suprafacial, it's antrafacial. So we basically say it as simple A. This is the case of sigma bonds. So this is the case of pi systems. Now let's do 2 examples, shall we? So example number 1. We are going to be, we have this particular reaction. Okay. So here we have the 2 orbital pairs which are going to interact with each other. Now we are asked to identify what is the interaction between these 2 orbitals. So let's say the interactions are like this. Okay, interactions are like this. So basically this orbital rotate this way, this orbital rotate this way, and this orbital rotate this way, this orbital rotate this way, and form the new 2 bonds between these 2 areas, right? And now when this happens, right, we have to identify the particular interactions between these 2 orbitals. So if I talk about this segment, what would be the interaction? As you can see, there are 2 orbitals and both are forming the new interactions from the same side. If I put the positive and negative, you can see both the orbitals are forming the new interactions from the same side, right? Same part. So this should be suprafacial. When you look at this segment, right? When you look at this segment, you will see the same thing, right? The interactions are forming from the same side. So it's again suprafacial. But this is not how we denote it, right? This is not how we denote it. We have to denote this particular scenario with the number of pi electrons. So if you look at this segment, right? If you look at this segment, there are 4 pi electrons. Here, look at this. Let me take another color. Okay. Here, there are 2 electrons here. There are 2 pi electrons here. There are total of 4 pi electrons which are involving in the interaction. So there are going to be 4 pi electrons which are interacting with the other party from the suprafacial case. So this is how we mention the particular interaction between 2 orbitals. So again, let's go to here. You can see there are only 2 pi electrons. Only 2 pi electrons. So it's going to be 2 pi. What's the faciality? It's suprafacial. So it's S. Now the important thing to remember, right? This is not the number of pi electrons which contains in the particular segment. No, it's not the number of pi electrons. It's the number of pi electrons which is involving in the interaction. So let me give a quick example for it. Let's take this scenario. Okay, if you look at this scenario, let's say we have the 2 interactions like this. Okay, what would it be, right? First of all, what you have to do is you have to put the orbital charges, not charges, I mean orbital parts. You have to divide it. Now you will see the both interactions, right? Both interactions are happening from the same part, which means both segments, right? Both segments are suprafacial. How we can write it? Now first we have to identify the number of pi electrons which is involving in the particular interaction. So if you look at this segment, there are only 2 pi electrons, so it's going to be 2 pi. And the faciality, both interactions are forming from the same side, so it's going to be suprafacial. But when it comes to here, you will see there are only 2 pairs of pi electrons which are involving in the interaction. So this particular pi bond, here look at this pi bond is not involving in this part, right? It has nothing to do with this part. It has nothing to do with it. So we do not have to include this particular pi electrons for our segmentation. So there this only be 4 pi s, because only 4 total number of electrons, total number of 5 electrons are involving in the interaction. So the interaction would be suprafacial. So I hope you got the idea, right? Okay, let's move on to the last example. What about this? Now the first thing we have to do here, these are the two orbitals. These are the two orbitals here. Now the interactions are like this. Okay. What happens now? Now first what we have to do is we have to put the positive and negative parts in the orbitals. So here, if you look at this segment here, the upper segment, right? What we have to look at is the faciality. Now, when you look at the faciality, you will see the both interactions are coming from the same part. Look at this. The interactions are coming from the same part. So it's going to be suprafacial. Now, if you want to mention the particular, particular symbol for it, right? So you have to see how many pi electrons are involving. So there are 4 pi electrons, and it's going to be S. Now the trick is here. Trick is on this part. You will see now in this case, one interaction is from the positive part while the other is from the negative part. So it's not suprafacial, it's antrafacial. So the symbol would like be 2 pi A. 2 pi is the number of pi electrons which is involving in the interaction. Now the A, which means the antrafacial. So this is antrafacial because the two interactions are coming from the opposite parts. So this is basically the faciality. This is very important when it comes to our next video, which is about the transition state theory. So we will use lot of these terms and these facialities when it comes to the transition state theory. So I hope you are okay with it. If you have any particular problems, please feel free to comment below. I will try my best to answer those questions. And yeah, we will meet on our next interesting video, which is about the transition state.